Alright, today I'm going to be fixing my circuit opening relay, and I thought I'd make a video since this is $80, $90 for a new one, and I'm going to be fixing mine for $5 today. And they can also you can also modify this circuit so that if you have issues with your truck losing fuel, specifically because of the AFM signal cutting out to your circuit opening relay, you can put in a larger capacitor, which can hopefully solve that issue. Most of you probably know how a relay works, but for those who don't, it takes a small electrical circuit, and when that's closed, it completes another circuit within the relay, which allows a larger amount of current from a different circuit to pass through. This one is goes to your fuel pump, of course, and it has two coils on a circuit opening relay. This is from the start, and this is from your airflow meter, or your mass air, MAF, if you have a newer vehicle than I do. But so current flows from between these two pins, or between these two pins, depending on which circuit it is, and through the coil, which is insulated thin single strand wire, and generates a magnetic field which closes this on the end here. And that completes a circuit between these two pins on the bottom when these are touching, and that allows current to flow through your battery, through your EFI relay under the hood, through this, and back to the fuel pump. And a circuit opening relay is a safety feature so that if you are driving along and get in an accident and your AFM will close, the circuit will open and your fuel pump will shut off. Whereas if you had it hot wired to run all the time, if your key was on and you'd gotten in an accident, fuel could potentially be spraying all over the road and start on fire and burn you up. So alright, well, first of all, real quick, I just wanted to show you with the AFM, in case some of you haven't seen that before. So you have in here, your circuit is senses the airflow coming through with the your vane in there. That's the vane airflow meter name, which when that moves, it rotates this, which is on this spring underneath here. And as soon as that rotates, as soon as there's air flowing through your box, this contact right, and that's too close. This contact right there closes, which allows current to flow through your circuit opening relay. And I can see a problem, those of you who have done the mod like I have, where you increase the tension on your spring to lean out the mixture a little bit for that 3VZE engine. That's going to put more tension on this, which might make your circuit more likely to open and lose power to your fuel pump when you're driving along if you let off the gas suddenly or something. Alright, back to the relay. So here I have, just for illustration's sake, I got a 1000 microfarad capacitor. The factory one is 130 microfarads. These are both 25 volt. Specs, factory one, 130 microfarads, 25 volts, and 125 degrees Celsius, which seems like overkill considering water boils at 100. I don't think you really need that, which is why the one I'm going to be using eventually here is 105 degrees Celsius. But this is just to illustrate what will happen if you put a really large capacitor in, which some of you may benefit from. I know that people have thought they've had issues with loss of fuel while they're driving along. So mine is removed already, of course. Yeah, right with the capacitor, you want the negative, which is the side that has this black stripe down it. Or if you have a black capacitor, it has a white stripe down it, and the negative sign, sort of, that's what you can call that thing, the rectangular. You want that on on this side. So you want the striped side like this on your circuit opening relay, and that's important because otherwise these capacitors can blow up, which would defeat the purpose of putting it in and kill your entire relay. And yeah, the reason I'm doing this in the first place at all is because my capacitor, as you can see, is leaking. Got wet, so when they're leaking like this or when they swell up, it's a pretty sure sign that they're bad. And the first fix is obviously to fix the leak which caused it, which seems like all these vehicles have along your passenger side column, which runs down and seems to find its way into the circuit opening relay no matter where the leak is. So after you fix the leak, then you can put a new capacitor in. So here, without the capacitor, you can see that when I hook up, I have these two are connected to a battery, these two clips. When I connect that, you can see that the circuit is closing. A little bit. So those two pins on the left-hand side here, and as soon as I let off, as soon as I open that circuit, the power to the fuel pump would be cut off. Whereas now if I put this 1000 microfarad capacitor in circuit there, and I tap it, oh, I'm sorry, that's the start circuit anyway, so the capacitor isn't going to affect it. But it's the same idea. And you can see, alright. Yeah, same thing. So now with the capacitor in circuit, because there's no need for a capacitor in your start circuit, but this is the run circuit from the AFM. So now, same thing, but you can see if even when I tap it like this, the circuit stays closed for about half a second. So buys you a little bit more time. You know, you can lose that AFM signal for about half a second, and you're still good. You could actually fit even a capacitor even bigger than this in there. You know, if you look online, they have this one's from Radio Shack, but you can get 2200 microfarads for less than $3 shipped to your door. I think they're $3.99 actually, but I didn't feel like getting one of those. So there you go, 1000 microfarads, and buys you some time. I'm going to be putting in a 150 microfarad in this one, just because that's a more standard size, and I haven't had issues with mine losing fuel. But even if you haven't had issues, it's good to have a capacitor in that circuit, because you never know when you might have an issue like that. And it also prevents sparking, where when the contacts in here open and close really suddenly with a lot of current going through them, you can arc out your contacts. If you have an issue with an arced out contact here, you could also fix that if you were so inclined by prying that back a little bit, putting your, you know, you have to bend this metal back, so I'm not going to do it because there is a chance that it might not go back together perfectly smooth. But if you bend this metal out and bend this out, put your soldering iron on the outside here and touch the inside with some rosin core electrical solder, which conducts electricity. That's going to basically give you a fresh contact. So you could put a dab of solder in between the two and adjust the bend, and that should solve any issues with arced out contacts if you're having that. Alright, final step here is just to solder that on. So yeah, the capacitor goes in these two, just like that, as you see. And that other thing underneath is a 47 ohm resistor. And odds are you're not going to need a new resistor, since those things are a lot less fragile than capacitors are. But if the, you know, you can test that with an ohm meter, and should be 47 ohms. And if not, you can replace that the same way that I'm doing this. Let's see. Well, you're not going to be able to see through that thing, huh? But I can. So, put that thing back in position. And it's a lot smaller than the factory one, probably because of the temperature rating. But, yeah. Joints are good, and that should do it.